Let's solve question 1.3 now. So we have a firm that produces output using low-skilled workers, and production is given by the following function. L is the number of low-skilled workers, and the price of the product is P, and the wage that we pay to the low-skilled worker is W. Now in part A, we want to derive the profit maximizing number of low-skilled workers. Okay, so to find out the profit maximizing number of low-skilled workers, we need to know the profit function first, as depending on the low-skilled workers. So what is profit? Profit is the difference between the total revenue and the total cost. Now what's going to be the total revenue over here? We know that we sell our product for a price P, and our quantity is the following function. So the total revenue will be price times the quantity, and the total cost will be the wage that we pay to the people that we hire. So that will be W multiplied with the number of low-skilled workers, so multiplied with L. That's going to be our profit. So this is our profit that we are looking for. Now to calculate the profit, we must do some substitution, because we know the quantity function is given as a function of the labor. It's theta times ln of L. So we will have here price times theta times the logarithm of L minus W times L, Now what can we see here is that we will have a certain relationship between the profit and the low-skilled workers. Now we have the term of logarithm here, and the logarithm is an increasing function at a decreasing rate, meaning that if we plot the relationship between profit and the labor that we hire, the low-skilled labor that we hire, we will hit a point of maximum profits, meaning the profit will increase with the number of low-skilled workers, but it will hit diminishing returns at a certain point, and we want to stop there because we do not want to diminish our profits. We want to maximize it and find out what is the number of low-skilled workers that we need for that. Now, how can we do that? Well, we know that on the peak of this graph, where the profit is maximized, there is no rate of change. The derivative, the slope tangent to that point, is equal to 0, meaning that we want to differentiate the profit function with respect to the number of low-skilled workers and make that equal to 0. So we will have profit derivative with respect to L equals to 0. Now what's going to be that profit derivative? We will differentiate every term. So we take the first term from here, P times theta times ln of L. If we differentiate that with respect to L, what do we get? We have the constants left, so that's P times theta, and we differentiate ln of L with respect to L, which is 1 over L, and then we do the same thing over here on the other term. W times L derivative with respect to L, that's going to be just W, and we make that equal to 0. Okay, we're looking for L, so let's take this term on the other side first. Let's take W over there. We will have P theta divided by L equals to W. Now, if we want to only write L as a function of everything else, because that's what we're interested in, well, that's just going to be by changing these places. We will have that the number of low-skilled workers optimally will be equal to P times theta divided by W, and that will be it, and we are done.